One of the most common questions that I often hear is, after spending days, if not weeks, writing software, how do I get that software to be accessible to people all around the world? That is, how do I build a seamless, continuous deployment pipeline through something like GitHub and host that software on something like Google Cloud Platform or Amazon Web Services or Microsoft Azure? In this video, we are going to be doing just that, an end-to-end walkthrough on how to write and deploy software with a continuous deployment pipeline. Let's get right into it. From code to production. So what are we doing? Well, like I had said before, we're typically spending, hours, days, weeks, months, what have you, to write code on our laptop or computer, and we push it up to a version control system provider like GitHub, GitLab, or Bitbucket. And what we're doing is we're saying, maybe to our team members, or maybe we're working by ourselves, we basically want to say, I want to merge this code into some main branch. And typically what you see in professional environment is people review that code and they nitpick it or add comments. And when everything looks good, then you get enough approvals and you merge it into the master branch. So master branch will be the central state of truth. This is the reflection of our system. Basically, like master branch would be the reflection of when you literally go to google.com as a hypothetical statement. And so that's what master branch would represent. Now, when you push up code for review, you're adding some new feature. So it's not on the server, it's nowhere. It's basically additions and deletions to master, the current state of truth, or some other branch. And you're basically saying, hey, guys and gals, please review my code. Please approve it if it's good. Let's go ahead and merge it back in. And this now becomes the new state of master. And so what happens here, this is where the continuous deployment or CD pipeline kicks in. So, and again, typically before you merge the code, all the tests will actually run to ensure that you haven't broken anything. But again, what a lot of people do is once it gets merged into master, it will again run all of your unit and integration tests as an automated pipeline. And that's kind of the first node or first step in our pipeline. Then what do? What we do is we package our code. This can be a variety of things. I'm a big fan of Docker. In this video, we're going to be talking about Docker. But what people do is they basically say, I have some Docker file that's going to package up all my code, expose all the ports that I need to be exposed, and I'm going to build a new image, right? So this is the new kind of state of my software, and I'm going to deploy this image to something like Docker registry, whether it's private or public registry. Then what you do is you say, all right, now I want to deploy my changes. And this could be something like, hey, Amazon Web Services or hey, Google Cloud Platform, either pull down this new Docker container and run it, or you can use something like Elastic Beanstalk, which we're going to be using, which you'll basically upload that Docker file and it will know how to interpret it and start running a new instance of your application in the cloud automatically. And it's a very nice, cheap way to do that. And so this is kind of from code to production workflow that we're going to be looking at. Development versus production. So for the dev server, we have a web container and it has, of course, this fancy development server and something like our index.html and the main JavaScript file. So this is the current state of our React application. When the web browser comes in and we're making requests to our dev server like localhost port 3000, that request gets proxied through the dev server and gives us a response, and that's how we see that icon and that text on the browser. Now, when we go production, it's almost identical, but we replace this development server again with something like Nginx or Apache, and it basically serves up index.html and the main.js file, and this is the response back to the client. Okay, so the server serves these files back to the client, and this is kind of how you handle requests. Okay, so this is what we're going to be building in this example. So let's go ahead and get started. We have a lot to cover, so I'm going to create a new terminal window here. And first thing I want to do is basically have something to deploy, right? So at the end of the day, we are deploying an application. In this specific example, I'm going to be using React and Node.js. But if you do not have that, or you're writing something in Java, feel free to follow along in a different language or framework of your choice. So inside of my desktop, so we'll keep this simple, I've actually already gone ahead and created this, but if you are following along and you want to create React app, you just do npx create React app, and then you name it whatever you want here, right? So I name mine deployment tutorial. So what I'm going to do is go into basically deployment tutorial, and this is just auto-generated boilerplate code. And create React app, if you're not familiar with it, basically gives you a development server with a bunch of Webpack config stuff and hot module reloading, and gives you a really easy way to prototype React applications kind of on the fly. So if I go ahead and run npm run start here, give it a second to boot up, this will basically run the application. All right, so the application pops up here. You can see there's another change here. If I actually go into the code, so I have it pulled up right here. If I go into this code in the source file, and I can just basically come in here and say, this is another update, and I save it, and if I go back to my browser, it'll actually automatically reload. And this is part of the benefit that we get with the dev server, as we had noticed before. So it's really quick to update. Now, in this tutorial, we're going to be utilizing Docker. And if you're not familiar with Docker, I have some videos on it. It's great for a number of reasons. I'm not going to go into too much detail, but the main thing is that, if you swap between different deployment pipelines, or you're running your stuff on different machines, Docker doesn't really care. If you have the Docker daemon installed on the target machine, it will run or create a container, an instance of your image that you build of all your code, and it will just work. It's really great, right? You don't need to worry about dependencies or libraries or specific versions. If you're running it on a different machine, it will just work. So with that philosophy in mind, we're going to be building a development grade workflow in Docker with all of our code in this case for create React apps code. And we're also going to have a production grade workflow, which will actually handle the deployment pipeline that we'll be using when we actually merge commits into something like GitHub and deploy it on AWS. So let's go ahead and look at that. First thing that I'm going to do is, first of all, I don't care about any of this code, right? This is boilerplate code that's given to me. I'm just going to use it at face value. I'm going to build a Docker file, and it's going to be used just for development, okay? And Docker file is basically going to say, how am I going to take the code that I have here in my repository and package it up into my container for it to actually run inside this little container? And there's basically just a few super simple commands that we're going to look at. And so the first thing I want to do is specify the base image. So if I come in here and I say from Node Alpine, so Node Alpine is a super bare bones Linux distribution, and Node basically is going to be installed on this distribution. So very lightweight. I'm going to set the current working directory to /app. So this is where we'll basically be storing all of our files in the container. And I'm going to copy the package.json file into app. So the dot is the current working directory in the container, and package.json, again, is specific to this project, but that's where all the dependencies are going to be defined. And the command I'm going to run is npm install. So npm install will scan for the package.json, and it will install all of the dependencies on the machine. The final thing I want to do is copy everything from my current working directory on the host machine into the container. And again, the current working directory is app, and I will boot up the container. When the container starts, it will basically run npm run start. And this is kind of the setup that we are going to have. So very nice and very simple. Now, one of the things that you'll notice here is that requests come into the development server, and they basically handle or interpret the request or packet that comes in, and then they give us some sort of response. Now we've added another layer here. We're dealing with a container. So we need to make sure that we're exposing the port of the container to allow requests to actually come in. Again, we have another layer of network abstraction over our software now. So we need to ensure that we have the capability to allow those requests to actually proxy through. Now, you can do that in Docker files, but one thing that I really enjoy using is Docker Compose. And this is just another utility that's used to facilitate Docker image creation and things like volume mounting, which we'll look at, and exposing different ports. So let's go ahead and do that. What I'm going to do is build a Docker Compose file. So you come in here, Docker Compose, I'll call it development, and the file type is actually .yaml. Now, what are we going to do here? Well, essentially what I'm going to do is first I'm going to specify the version of Docker Compose that I'm using. It's going to be version 3. And I'm going to start defining the services and things that I want to build here. So I'm going to build a new service. Let's just call it deployment, for example. And this could be named anything. It could be called My Cool Website, for example, or whatever you want to name it. I'm going to call it deployment, and I'm going to specify the build. So when I actually build this code, when I run Docker Compose, what Docker file is it going to represent or reference? And I'm going to set the build context. So this is where the Docker file exists. So the dot is going to be my current working directory. And then the Docker file, we're going to be very verbose about this, but the Docker file is going to be dockerfile.development. And this matches the file that we have here. Okay. So now what I want to do is expose some ports. So this will allow requests to actually come in. So I'm going to come in here and do ports, and it's going to be an array. So I do a dash, and I'm just going to say, port 4500 from my host machine gets mapped into port 3000 on the container. This is pretty much arbitrary, right? If you're hosting a web application on something like Amazon Web Services, maybe you would want this to be port 80. So things, when you hit your website directly, for example, it will map that request to port 3000 in the container. Port 3000 is what our React Dev server is running on. The final thing I want to do is mount some volumes. So volume mounting is basically a reference. So if I mount a particular folder, you can think of it kind of like a link or a pointer. So if I mount a folder that exists on my laptop into the container, if I make changes to that file on my laptop hard drive, it will be automatically reflected in the container. And this is how, in our development environment, we're going to get hot reloading. And so what I'm going to do is I'm basically going to say, I want to map everything from my current directory into /app, which is the working directory of the container. And one thing I'm going to add here is if I add /app/node modules, it will just ensure that I don't try and map anything from my hard drive to node modules, since we did install the dependencies in the container, so we don't need to kind of remap node modules into the container. And that's pretty much it. So this is how we create React app running locally, but now it's running locally via Docker. So let's go ahead and see if this works, see if we ran into any errors. So I'm going to go into my directory here, and you'll notice here are my Docker files. So in order to run this, I'm just going to do Docker Compose. I'm going to specify the Docker Compose file that I want to use, which is Docker Compose development.yaml. And I'm just going to do up, and that will start this thing. So you'll notice it's building deployment, which is the name of the service in here. And we'll just give it a minute to run. Now, just a quick note as this is running, you may notice that this is taking a while to run. And what basically the reason that's happening is because when we look at the Docker file, you'll notice that we're copying package.json, we're installing all the dependencies, and then on top of that, we copy everything from our working directory into the container again. And as you'll notice, again, we're copying all the dependencies, which we totally don't need to do. And so this will go from taking forever. What we can do is actually just remove the node modules. So I'm going to do rmrf node modules. This will take a second to delete. And now what I can do is I can actually just run this again, and it should be a bit faster. So you'll notice it builds way faster than it was before, and that's because, again, the dependencies are already in the container. We do not need to copy the dependencies from our local machine into the container again. That's redundant and completely unnecessary. And when we look at the output, it says, hey, it's available on localhost 3000. So you may think, okay, let me go ahead and open a new window here. I am going to go localhost 3000, and you'll notice, boom, it does not work. And the reason this is because this Create React app, this application is running inside of a container on port 3000, but it's not exposed as port 3000. Remember, if we look back at the Docker Compose YAML file, we're actually exposing it as port 4500. So I would have to come in here and type in 4500, and this is how we get updates. So this is actually running inside of Docker now. Now, if I come into my source code and I actually modify something, like I come in here and I say test updates and I save it, you'll notice that it immediately updates the Docker version of our application as well. And the reason is that because when we look at the Docker Compose, we have mounted the actual application source code into the container. So we'll get immediate updates. And this is a really great way to iterate utilizing Docker locally. A very simplified setup for that. Now, you may be asking, okay, how does this help me with deployments for production grade deployments? And that's what we're going to look at next. So I'm going to kill this. You can also run Docker Compose down if you want to kill anything that's running. Because we name this differently than Docker Compose.yaml, you actually need to specify it explicitly. So you do Docker Compose-f, Docker Compose development, and then you do down. And that'll ensure that everything is cleaned up. We're going to build the same thing now for our production environment, and this is the stuff that will get deployed to Amazon Web Services. What I'm going to do is I'm going to create a new file. I'm going to call it Docker file, and I'm going to create a new Docker Compose file. I'm just going to call it dockercompose.yaml. Now, very, very similar with some minute differences as to what we did before. So let's first look at Docker file. So Docker file, I'm again going to specify the base image, so node Alpine, and I'm going to just do almost the same thing. So set the working directory to app, so workdir/app. We're going to copy the package.json into the working directory, and I'm going to run again npm install. So from here, if you remember, I'm going to again copy everything over there, and the difference here is we are not running the dev server. So as I had mentioned in the beginning, the dev server is great for local development, but not production grade environment. So what I'm going to do is I'm going to get the static assets. And if we run npm run build, what it's going to do is it's going to bundle a minified version of all the code and all the dependencies that we need into just a couple files. Okay. And these are static files that need to get served from a server. And this is what when requests come through to our server, it will serve these, basically these static files and interpret whatever our request is to send back to the client. So those files will be generated in the build directory after running npm run build. So this is the first step. Now what we're going to do is we're going to do something a little bit weird, and this is called a multi-stage build. What we're going to do is actually add another build, and what it's going to do is use the files from the first build step in the second build step. And what we're going to do is we're going to get the actual server that we need. So this is just so we can get the static assets built from React, right? The thing that's going to run our React application. This is what we need to do to use that. Now what I want to do is take these static assets that got generated, and I want to make sure that Nginx, which is a server, I want to make sure that it can host these asset files out of a directory in this container. So Nginx has a image available on the Docker registry. So if you go into Docker registry Nginx, you can come into the Docker hub, and this is the image that we're going to be using. So basically tells you how to use it. So hosting simple static content. This is almost exactly what we're going to be doing. And it tells you kind of where to put your static assets. So we're actually going to put our static React assets into this directory and see if they can still be accessed, kind of like our development server. So what I'm going to do is I'm going to specify the Nginx base image here. And what I'm going to do is just say copy. And we're going to say I'm going to copy from the first build step. So everything is 0 index. So I'm going to copy from the 0th build step, which is here. And what I'm going to do is I'm going to pull from /app/build, which is where the static assets are going to get built. And I'm going to copy them into Nginx's open, basically where they serve static assets. So it's going to be under /user/share/nginx/html. And this is where static assets will get served and hosted within the server. And this right here will be the thing that we're kind of serving from. So this is what's going to run on our application server in AWS, for example. Is a Nginx server inside of a Docker container. Now what we need to do is build the corresponding Docker Compose file. So again, very, very similar to the first use case. We're going to specify the version that we're using, which is 3 in this case, and then the services. So Docker Compose, previously we called it deployment. So I'll just be consistent here and also call it deployment. And then what we need to do is specify basically the build context again. So I'm going to say build, the context will be my current working directory, and the Docker file, to be verbose once again, is going to be Docker file. Notice that it's not dockerfile.development, so slightly different. And the final thing here that we're going to do is basically just change this, the ports that we're exposing. So I'm going to actually expose port 80. So we'll come in here. I'm going to specify port 80 is going to be exposed to port 80. So Nginx is by default running on port 80 here. So basically what this means is if I were to hit, for example, localhost port 80, it would remap the request internally to the Docker container to the service running on port 80 and give me a response that way. And so this is how the compose definition file is going to look. So I'm just going to save that. So now what I can do, and I can even call this production if I wanted to, for example. Now what I want to do is I want to come in here and I want to say Docker compose up. And notice I don't need to specify a file in this case because Docker compose YAML is the default. All right, so after running this, you'll notice that it kind of hangs here. And the point here is that it's actually not hanging. What we haven't done is we haven't attached a -d flag, and that will basically run it as a background process. But it's actually running fine if you see this. The thing is, Nginx doesn't really give you a lot of logs until requests start coming in. And so if I were to actually make requests, then we would see logs. I think I might actually be having issues hitting on port 80 because I already have something running on localhost port 80. So don't think this will actually go through. Yeah, I'm already running Nginx in a different container, so I think there's a conflict here. But if I were to come in here and actually change this, and I can prove this, I can come in here and do like 8123. And if I run this one more time, it's actually a lot faster because things are cached. If I come in here and I do localhost 8123, you'll notice that you get logs, and this is the production grade version of the application that we're going to be deploying. And again, you may be asking, what makes this the production version? Well, we only copied over the static assets, and now we're serving them through Nginx. We are not relying on the React dev server, for example, and all of the fancy processes that run in the background there. So this is the optimized production build. And so that's what we have here. Now what we need to do is actually set up the deployment pipeline through GitHub and deploy this code to AWS. And in this case, we're going to be using Elastic Beanstalk. So this will require an AWS account. We're going to be using the free tier. It does require a credit card, but it will not cost you anything. So first thing we want to do is create a repository on GitHub that we can access this code from. So I am going to go to GitHub. I'm going to create a new repository, and I'm going to call this Simple Engineer AWS Deployment Tutorial. And I know that's a really long name, but I'm going to make it public and create it. All right, so I have a blank repository on GitHub right now. Make this a little bit bigger so you can see it. Now what we want to do is upload the code that we have written so far, or in this case, generated, along with our Docker files. So what I'm going to do is I'm going to copy, I actually don't have SSH keys set up on this computer right now, so I'm just going to be using the HTTPS counterpart here. And what I'm going to do is I'm going to initialize a Git repository in this code with Git in it. And I'm going to basically say git remote add origin and specify this as the repo. If you see something that says like origin already exists or is already defined, you can do git remote remove origin and then rerun this command if you need to. All right, so if I run a git status, it'll basically show all of the things that differ from the branch that we're trying to merge in. So I'm going to add all of these, and you'll notice that they are staged now, and I'm just going to commit them and call this initial commit. And we will go ahead and push this directly to master. So almost instantly, you should see all of the code now reflected on this repository. And this is really useful because now what's going to happen is as you make commits or changes to the master branch, what we're going to do is actually package up our working application and deploy it to Amazon Web Services. So before we go any deeper in the world of GitHub, first thing we need to do is go over to Amazon Web Services. So I'm going to go into the AWS Management Console, and it's going to probably ask me, okay, so I'm already logged in. So once you log in, you'll be granted with the main console here. I'm just going to go and type in Elastic Beanstalk. Now, Elastic Beanstalk is an orchestration offering from AWS, and it's really good for basically handling the deployment of applications. It does automated load balancing and scalability, and it utilizes S3 to store some of your application code that it deploys. It's very nice overall. You can see some of the things that it does. So capacity provisioning, load balancing, automated scaling, etc. And you do have health monitoring as well, which I believe is through CloudWatch. So very, very nice thing. First thing that we want to do is go ahead and create the application. So I'm going to come in here and I'm going to call this Simple Engineer Deployment Tutorial again. And I don't really need any tags or anything. The platform, I am using Node.js. If you're using something like Java, then you would select Java. But I'm using Node.js. Platform branch, I'm going to use Amazon Linux 2. Just a note, if you are following along and you are familiar with Docker and you choose to not use Docker Compose for whatever reason and you just want to use a Docker file, Amazon Linux 2 on Elastic Beanstalk will by default look for a Compose file. So if you just want to use Docker file, go ahead and select Amazon Linux. This is kind of the previous generation version of this. But I am using Docker Compose, so I'm going to be using Linux 2. And I'm going to go ahead and create this application. This process in its entirety takes probably 5 to 10 minutes, so I will just let it complete and we'll come back. All right, so just a few minutes later and you will be redirected to a page that looks like the following. And you'll notice that basically you have an application and you have an environment. And you'll notice that you're granted with a URL that looks kind of like the name that you specified. And when you click on this, it'll basically give you a congratulations. This is the default AWS Elastic Beanstalk website that they load up. And no worries about this. We're actually going to be overriding this through our GitHub deployment. But this is good. We can see that the health check looks okay. And then here are some of the event logs that we can see as we are kind of messing around with this. So now what we want to do is set up through GitHub. We want to basically say anytime we make a commit on the master branch, how can we deploy our application, which in this case will be our Docker file. How can we run our most updated code off the master branch on Elastic Beanstalk? And this is basically the server accessible all around the world. And so that's what we're going to look through. And we're going to be using GitHub Actions. So if we go over here at the top of the repo, we're going to click Actions. And I'm just going to see, you can see that there's a lot of different things over here, but I'm just going to set up a workflow myself. So I'm going to actually just delete everything, and I'm going to name this main.yaml like so. And we're going to walk through a series of steps. So like I said, this will actually be completely available on my blog, and we're going to kind of go through this line by line. So what I'm going to do is I'm going to copy the first chunk here, and I'm going to explain each and every line here, but it is a bit tedious. So this is just a name, and I can just call this like, deployment from GitHub to AWS, right? And this is going to run anytime I push to the master branch. Okay, so this is the action. This is the branch that I want this to be relevant to. And so the next thing is basically I need to build a job. Okay, and make sure that you have no typos here because YAML is fairly tedious. I'm going to come over here and I'm going to just kind of copy the first piece here. So jobs will specify all the things that I want to run after my code gets merged to master. So make sure the indentation looks okay. Again, so actually this is supposed to be at the root level. I'm going to have a job in here called test and deploy. And actually, this is not running any tests, so I'm just going to delete this and do deploy. And it's going to run on Ubuntu. So these jobs in GitHub, different than Docker, it's running the job on Ubuntu, the latest version, and it's going to run a series of steps in sequential order. So the first thing it's going to do is run this checkout action, and the checkout action is actually an action built by the GitHub team. If we check it out, no pun intended, we can see that this action checks out your repository under the GitHub workspace environment variable so your workflow can access it. So really, exactly as the name states, this action is going to check out this code, right? This code here into the virtual machine running Ubuntu's latest version. So that's the first thing that we're going to do. So nothing too fancy. The next thing that we want to do in this workflow is we want to basically generate the deployment package that we want to use. So generate deployment package. Now, and I'm actually going to just copy this to my other monitor here, and we will walk through this. So generate deployment package is going to be the name. And what we're going to do, the way that Elastic Beanstalk works, at least for this action that we're going to be using, is it takes in a zip file. And in the zip file, there's going to be a Docker file that it will scan for, or Docker compose file in this case. And it will use that to actually build our image and initialize an instance of our image. So it'll run a container. And all of these assets, basically all the files in our repository, get zipped up and placed in an S3 bucket, which is essentially a virtual hard drive running on the AWS ecosystem. So I know that's a lot of stuff there, but I'm going to come in here and I'm going to say, I'm going to run, and I'm going to zip recursively a new zip file called deploy.zip. And I'm going to just zip everything, and I'm going to exclude anything that's related to node modules. Okay, so we don't want to run or package up any node module stuff. And that's kind of the first piece. So now that I have my zip file, this I'm actually going to just copy and paste. These two steps that I'm going to have here are solely used just to get a unique timestamp value that I can add to the file that I upload to AWS. So first thing I'm going to do is have a step that gets me a timestamp. So this will be basically the current time that this step runs. And then what I'm going to do is there's an action, a GitHub action that does string replacement. And this again could be a little bit overkill, but I like the way that this works. So string replacement, what it'll do is it will take in the current time. So if I go to steps.current-time, which is the ID that we are using here, and I grab the outputs object, and I grab time, what I'm going to do is just run a regular expression replacement here. And this just does some formatting on the time that I use in the final step. So if that doesn't make sense, I'll show you one thing that you can do to kind of avoid these two things, but I do like this to have a timestamp to kind of version when I deploy my software. Okay, so the final step is basically deployment to Elastic Beanstalk. So the action that we're using here is this Beanstalk action. The current version is version 14, and you can actually check this out. It's pretty cool. So I'll come in here, and Beanstalk deploy, open source thing, you can check it out. Basically, is a GitHub action that's used to submit your code to Elastic Beanstalk in a GitHub action. So pretty straightforward. You'll notice here that I have environment secrets here. And you may be asking, where do these come from? Well, they come from the secrets that are defined on the repository. So what we're going to need to do is set those up. But in order to set them up, we're going to need to actually get those secrets to begin with. And the way that we do that is we need to build a new user. So back to AWS, what I'm going to do is I'm going to search for IAM, and this is Identity and Access Management. So if I come here, you'll notice a bunch of stuff. What I'm going to do, and this is kind of a tangential philosophy in AWS, is you don't really want to attach specific policies to a user itself. Typically what you do is you build a group that has policies defined, like what it has access to. Does it have access to Elastic Beanstalk? Does it have access to specific S3 buckets? And then you put the user under that group. So what I'm going to do is I'm going to build a new group here, and I'm going to call it Elastic Bean Admin Group. And what I'm going to do is I'm going to give it a policy. So I'm going to search for Beanstalk, and I'm going to isolate its access to full access for Elastic Beanstalk here. So it's going to be able to do everything that Elastic Beanstalk can do in this ecosystem, and I'm going to create it. So that's my group, and what I'm going to do is now create a service account under that group. So under add user, I'm going to type in GitHub service account, and I'm going to give it programmatic access. And what I'm going to do is just add it to my Elastic Bean admin group, and we'll just go ahead and continue. I don't need to add tags, and I'm going to create this user. Now, this may look familiar, but this is the access key and secret access key that we're going to be using. Do not share this information, okay? I'm obviously going to be deleting this account after. You'll never be able to retrieve this again, so make sure you download a CSV copy of the credentials. So what we do in this point is we need to store these as a secret on GitHub. So in order to do that, we basically go back into our repository. I'm going to open up a new tab under settings. You'll see secrets, and I'm going to add a couple secrets. So you'll notice the first one is called AWS Access Key ID. So I'll come in here and I'll create one called that, and I'll copy the access key and create this. And we'll go ahead and create a new repository secret under the AWS secret access key. And we will go ahead and copy this as well. Make sure there's no leading or trailing spaces. And I'll go ahead and add this. All right, so I have my two secrets added. So now my GitHub action should have access to that. Next thing is the application name and the environment name. So if we go back and we look at Elastic Beanstalk, you'll notice that if we go to applications, This will be the application name, and the environment name is actually adjacent to it. So I'm just going to go ahead and copy this. This is the Simple Engineer deployment tutorial is the application name. And the environment is this environment here. And the version label is basically why we did this timestamp string replace stuff to begin with. So what it does is it has a prefix, so simple engineer deployment. And what I do is I pull from the previous step, format time, the replaced time. So format time is the ID. Okay, so that's how I access it. I go into the output of this step and I pull out the value in the object called replaced. And this is going to be a nicely formatted date. And this allows me to just kind of track changes over time because these files get uploaded to S3. The deployment package it's going to reference is the deploy.zip file. This is what we packaged up here. Also, just one note, the region is where you created the Beanstalk application. So if you come up here, you'll notice that I am under US East 2. So make sure that these things match or you will get a failure. Some people, obviously build their stuff based on where they exist or where they're going to have a lot of users or where they're basically building their application. So make sure that it matches. And that's pretty much it. So this is also just a recap. Anytime that I push commits to the master branch, this job is going to kick off. The job is the deploy job. It's going to run on the latest version of Linux Ubuntu. It's going to check out the code, package all my code except for node modules into a zip file. I'm going to get a nicely formatted timestamp to use as my version label, and I'm going to push this zip file, which contains my Docker Compose file, over to Elastic Beanstalk, and it will just automatically know how to interpret that. This is the credentials that I use to gain access to that environment. And once it's all done, it should deploy the code directly to Beanstalk. So I'm going to commit this new file. And once it's committed, I can actually go back into Actions, and you'll notice that a new workflow was submitted, a new task is running, and it's queued. So deploy is the name of the job that we have, and you'll notice it'll start setting up. So let's just give it a minute to run. So you can notice that it almost instantaneously checked out the code and generated the zip file, got the timestamp. So you can actually see in the logs things that it's doing, which is pretty nice. And then kind of what's happening here. And deploy to Elastic Beanstalk should take just a couple minutes. So you can actually go back into Amazon Web Services and see if there are changes being done to it. So you can actually notice that Elastic Beanstalk is updating your environment. This is from this GitHub action. So this will take a couple minutes. What'll also happen is that if you go to Amazon S3, this is where the asset files get uploaded for this particular deployment. So Beanstalk will have created a new bucket for you. And inside, you'll notice that here's Simple Engineer Deployment Tutorial. And this is the interpolated string value with the string replacement that we ran in the GitHub action. This will be the actual files that Elastic Beanstalk is pulling. So if we go back to Elastic Beanstalk, we can check out to see where we're at. It's still running, so we'll give it another couple minutes. All right, so looking back at our deployment job, it looks like everything was successful, which is always a good sign. So if we go back into AWS, health status check is okay. It says environment updated completed. So now if we go back to our Elastic Beanstalk URL, you'll notice that here we can see our React application. So all is well. So it looks like we're complete. Just one final note before we break off and summarize is if you want to delete this and not get charged, just go into your applications and select the application, go into Actions and hit delete application. It'll require you to put in the application name. So go ahead and copy this and just hit delete. and that's all you need to do. So that's all we got. So thanks so much for watching. If you have any questions, feel free to drop a comment or tweet me at the Simp Engineer on Twitter, and I'd be more than happy to respond. So thank you guys so much for watching. I know this was a long one. Please like the video and subscribe if you enjoyed this content, and I will keep making more. All right, take care.